Hello everyone. So now today we're gonna study about what are the linear regression, what are the multiple regression, and also what are the generalized method of the regression. And moreoverly, as I discussed about, like we will be making a project that is simple linear regression. In a simple linear regression, we will be finding out few points like how to import data, how to import libraries, and also how to generalize the data in a basic format. So now, for starting that, let's know what is linear regression, what is multiple regression, what are the basic agenda of the regression actually. Okay, and most probably the discussion about that would be the basic format of that. So let us know about what are the basic format of linear regression. So what is basically a linear regression is all about? So linear regression, in the most simplest word I can show you about, or I can tell you that linear regression is a supervised machine learning model. So we would be starting first of all with linear regression. Let me just reduce the size of the pen. Okay. In a linear regression, in the most simplest word, if I'll say that it is supervised machine learning. Okay, and this machine learning model is used to find the best fit linear line. In this model, basically, we find the best fit linear line between the independent as well as the dependent variable. That is to find the linear relationship between the dependent as well as the independent variable. So what happens is we need to find the basic details of dependent as well as to the independent. Any of the variable we can find out, but it should be the relationship between dependent and independent. Okay, either we used to get it as a linear and non-linear. Okay, either it can be linear or it can be non-linear. Okay, or it can be development dependent or it can be an independent. Okay, so linear regression is of two types. Okay, in the linear regression, first type is your simple linear regression. Okay, first one is your simple linear regression, whereas second one is your multiple linear regression. Okay, so in simple linear regression is where what happens in this is only one independent variable is present and the model has to find out the linear relationship of it with the dependent variable. Okay, in particularly this part we have only and only one independent variable. Okay, only this is to be present as one independent variable in this. Getting my point? So it has to be dependent on it has to be varies from another dependent variable to be formalized with. In this we have only one independent. I'm just writing in a short form. Okay, and this has to be varies or realized by a dependent variable. Correct? Basically what happens in this format, we come to know about what are the basic criteria to formalize with the basic variables that it has presented by. Okay, the presentation of your variable is very much important. Whereas what happens in your multilinear regression, we have more number of independent variable. Okay, whereas in simple we have only one independent variable, but whereas in a multiple linear regression we have more number of independent variable which are dependent upon any of the model, because we cannot justify a model in a given situation. Okay, so it automatically find out to with I need to make a relation. Okay, it we cannot impose in this like we have to make a relation on this. No, it automatically makes a relation, whereas the standardization happens with the different allocations. Now, what is a definition of? I'll make a line over here. Okay, now what is a basic definition? I would say, what is a basic equation of linear regression? Okay, the basic equation of linear regression. Now, a basic equation of linear regression is y is equals to b naught plus b1x. Correct? Now, over here b naught is your intercept. Okay, and b1 is a coefficient, or it is a scope, we can say coefficient or scope, basically we can say about. Okay, coefficient or scope. Oh, sorry. Correct? Let me just give another page of it. Okay. Okay. Either b1 can be coefficient or a scope, whereas x is your independent variable. X is your independent variable, whereas your y is dependent variable. Correct? Y is our dependent variable. B naught, the equation is y is equals to b naught plus b1 x. Now b naught is your intercept, b1 is your coefficient, or it can also be seen about the scope. X is your independent variable, y is your dependent variable. Okay, now moving forward to what is an equation of your just give me a minute, let me synchronize this. Okay, so what is equation about the multiple regression? So equation for multiple regression is so the equation for this is y is equals to b naught plus I times, or we can say simply we can write b1 x1 plus b2 x2 plus b3 x3 plus up to so on. We can go to bn xn. Okay, so what is b naught over here again? So again the b naught is intercept. Over here again the b naught is intercept, and y is your dependent variable, and x is your independent variable. Okay, so it will differ. So b1 b2 b3 bn, or we can say b1 b2 b3 b4 b5 bn, okay, up to bn. These are your independent variable. Independent variable of whom? Of a slopes. Okay, these are the independent variable of whom? It is independent variable of slopes. Correct? So now what happens when you have an independent variable also, dependent variable also, and a sectional coefficients also? What happens in this? You can verify accordingly. Just a minute. Okay. So we can clarify this all the linear regression in a one terms. Okay, and the slopes of this can vary. It is not fixed, it is not determined, it is not actually formalized or anything. Okay, this can be changed anytime. This can be changed at any section, any point, any variable. Now, a linear regression model's main aim is to, what is the main aim of the linear regression is, its main aim is to find the best fit linear line, whereas to optimize the value in this as an intercept part and the coefficient part, such as error is minimalized or not. Okay, error, what is now error? Error we will be listening in a very short terms also, in a long terms also, but what is the actual meaning of error? So error is the difference between the actual value to the predicted value. There will be the difference between actual value and the predicted value, and the basic aim and the basic goal of this is to reduce the difference in that. Okay, now what happens if we need to difference short down the difference or reduce the difference? That depends. Now let us understand this through a graph. Okay, I am making a graph. I hope if it is not much clean, but yeah, try to understand. Okay, so I'm just giving 15, each gap of 20 or 5. Okay, 20, 30, 35 and up to so on. Okay, now if I'll stimulate over here up to 100, 200, 300, okay, and raise a bar. Okay, let me just take it to the 10 also, and raise the bar up to this. Okay, and what will be happening if we point out some of the points? Okay, if I'll say this is, or we have more points, or this and this, just a rough example. Okay, there's nothing to remember, or just understand this point. Correct? These are the slopes I am building upon the variable axis. Okay, now suppose if I have a value over here, okay, and I need to approach a value to the up to this value, correct, and we have this section, correct. So it will be depending upon, like, this is the x-axis, this is your y-axis. Okay, so what it will be showing to you is your x is a dependent variable which is plotted on the x-axis, and the y is dependent variable which is plotted, independent variable which is like plotted on the y-axis. So here the dots, wherever the dot it is, so in the this dots are representing as a data points, that is the actual value of it. Okay, whereas the b naught over here, so what is the b naught over here? Okay, so b naught is your variable axis which will be giving you an intercept. So b naught is 10. Okay, so this is a b naught, we can say this is a b naught which is intercept, and it is being sloping to the x-axis. Okay, so b1, what will be the b1 is, this will be the b1, correct, and there would be error also. Suppose this is not an interception point and it is not at the particular point, so this will be the error. The blue line, that is like this one, if I'll color this out, the blue line, it will be best fit line, or to be predicting the models in this, and that will be the predicted value also, that will lie on the blue line itself. Okay, now the vertical distance between the data point and the regression line is known as error. It is also known as the residual of it, and each of the data point, which is the residual, and the sum of all differences is known as sum of residual or the errors of the residual. Correct? Now what are the assumptions? First of all, I'll tell you what are the assumptions of linear regression. Yeah, so let me just build something at the straight line. Okay, this again, if I'll make this, okay, and again the third graph. I'm just telling you what are the assumptions of the linear regression. basic assumption of the linear regression is, first of all, the linearity should be there. Now, how the linearity should be there? Basically, what is linearity? So linearity states that it should be a dependent variable, that is y, and it should be linearly related to independent variable. Basically, the assumption comes to check the plotting as in sector point or the scatter point between two variables in that. So if I'll say that this is something linear, upside linear. Okay, this is upside linear, and let me just make a point over here. Okay. Correct. So this is the linear. Okay, this would be the linear. How many times of linearity should be there? So upgrade down, curve down, or there should be the line straight down. Okay, it depends upon. If I'll say that, okay, there are the points which are on the line itself. So this is either we have a curve. Oh, I think the curve, I think I made wrong. It should be the hyperbolic or the similarity-bolic. Okay. Try to remember the linearity should be according to this point. Correct. So next comes is a normality. What is normality? So the normality would be xy axis. Okay, that should be normally distributed. There should not be like, okay, this point is a variable section or not. No, it should be the QQ plots or the HH blocks or the KDH plots. Either it can be histogram also. So for the normality, you can simply draw a curve. Okay, this type, or just to remember, nothing else. It should be okay. It should be a properly curve. Okay, either we have the hypermind or we have the sectional point. Okay, so this is your positively skewed, this is positively skewed, this is negatively skewed, and this is your normal distribution. So this is the way to get through a negatively skewed, this is the positive skewed, and this is your normal distribution. Correct. The very third is your homoscedasticity. Okay, and in this you need to just get out the variance of the error terms, and that should be the constant, that is the spread of the residual should be there as a constant for all the values for x. Okay, this should be an assumption, that should be plotting the residual point, or it can be the particularly the degree of information. Number fourth is your independence. So in the independence you have the correlation. There should be no correlation with any of your independent variable, or there should be assumption. Okay, either it can be, we can take like if a person has an age of 30 years and they are going to a party. Okay, we will be checking out like the age barrier. Okay, in the age barrier we will be standing out the basic detail of it. Okay, in the basic detail we need to know about what are the basic affirmations in that. Okay, and the affirmations are being digged out throughout. Okay, now rest of that we will be starting. Let's do some of the project section also. In the project section you need to set a term, your Google Colab notebook. Okay, let me just share the Google Colab now. So our project is car price prediction. Now how the car price prediction we're gonna judge out and make out. So what about the basic building of the machine learning models as well as the architecture of it in the machine in the car price prediction. Okay, first of all we need the basic data from where we're gonna use it. Okay, so I'm dropping down a link to get your basic data set. Okay, so the data set is this. the car price assignment.csv. So we have a lot of entries in this as in data set, and you need to inspect this data with basic formulation. Then you need to prepare a data as an id column, live columns, mileage columns. We can see a lot of sections are there, whereas the car name, fuel type, drive wheel, wheelbase, car length, engine type and all. Okay, that is particularly one thing you can create out. Okay, so now what are the basic detailing of your project can be done accordingly. Okay, the accordance of your project is to be determined with the most of your points actually. Okay, let's carry on with our project now. So you need to make a Google Colab notebook. From here you can go and search it out. You can go to the file. After that you can open notebook or upload a notebook or new notebooks. You can select out. Okay, let me just tell you how to do it. I think it is visible particularly to you. Yeah. So basic setup is you need to import the drive, whatever you have been working upon from, and you need to mount it. Okay, suppose this is, and if I'll say that I need to drive the mount, and it can be this, and you can enter shift plus enter to allocate and to connect the basic drive to this Google Colab notebook to this. Okay, after that it will be asking you few of your basic permissions, and you can say that connect to Google Drive, and after that you need to continue with this part. Okay, account, and it will be connecting automatically and your code will be run. Okay, if you are not connecting, there will be the message error that it is not being able to connect. Okay, so let us start now with importing some of the libraries. We will import libraries. Okay, just a minute, let me comment this. Correct. After that we will import number. Okay, then we will import pandas as pd. Again we will be import matplotlib. So it's already there. You don't need to waste your time as always. Okay, you can auto complete this. Then we will import cbone as okay. While you write a code, you can also run the shell so that you can get an idea that you're not making any mistake while writing the code. So it's simply enter shift plus enter. Okay, so you can see over here the tick mark, so it means like your code is running. Okay, now we will be reading a file. Okay, now we will be stucking to a file, like what file we need to import for. So I'm writing it is a csv file. We'll simply import this content. In the content we have a drive file. Okay, in a drive file you can simply get out like what, or you can copy your the path of it also, but it's simply good like if you know the where the your file is. me just run it again. Is that fine? Okay. Okay. Assignment pd.csv. Okay, let me just copy from here. Okay, so you can simply carry on with basic detailizations of your data. Okay, if we will run this cell, you will be getting the details of your car head, and in this you have the car heads like wheelbase, car length, car width. Okay, every detail of it, and it will only and only goes to the 5 rows and the 26 columns. We have 26 columns in this, and we have given a particularly detail of like we need a 5 only, or we can show up to a lot. Okay, just we don't need it, so we're not continuing to this. So if we will ask about the new shape, I need the car shape. Okay, if I'll enter this, so it will be giving me 205.26, correct? Again, if I'll say that instead of car shape I need cars info. Okay, in the car info I need it. So if I'll press shift plus enter, so it would be giving as a basic class of it, and in the class you can see the simple basic headings of it, which is the 26 columns of it, with the various degree of information, and also it has the count, the data type, and the total number of data types. In total number of data types, we have float that are varying for 8 types, and int, object. Okay, and also it will be giving us the memory used in this. Okay, basic memory, it has to clarify that how much memory it has to use. Now comes what is data cleaning. Now we will do a data cleaning and preparation of it. The data cleaning and the preparation, basically it has a degree of information where you can solve out a basic detailing of it. Let me just, if it's possible to increase the size of the text. I don't think so. Okay, okay, so we will write the new section only instead of this. So it is data cleaning and preparing. Correct? So in data cleaning and preparation, what we will be doing is we will be splitting the company name, or we can searching out the company's name as a subject part. Okay, in the particular format we will be writing company name. Okay, in the company name it is the cars, which is it, and in the car we have basic the car name. Okay, it will auto generate it out, and after that we will be applying the lambda function to this. But instead of the lambda function, we can simply write out the basic degree of the head. Okay, the degree of head we can simply split out, and the lambda function can be used in the splitting the name or the car column name or any of your row name or any of it. Correct? In the basic format we don't need to use it every time, but except to this you can get out for the excess what excess you have, but in place this with the value true. Correct? With the value true, if you will be doing is that is the basic thing you can get out. Now we need the cars head, After that we will run this. Okay, there is an argument error. Let me check what argument error is set. Let me replace this again, and after that we will see the value error is there. The company name error, the company status name, the company allocation name. Okay. Okay, it would be already existing, so that's why it is not giving you a car name. Okay, but it is coming to be the true. It will give you a name error also if you are not searching for this. But what if, like, we can say the car dot company name. Okay, and that should be unique. Correct? That should be the uniquest part. So it will be give you an array. Now what is the array? It is Alfa Romeo, Audi, BMWs. This is the unique car name. What is there in the data set? This data set. Okay, and this data set is the observation part of your the names of the car you entered. Okay, what if instead of your car name unique, we don't use unique part? Okay, so you check one thing, that what would be there. So it will give you a type error because it is already being passed through a certain point. Okay, let us do the running this cell actually. So it is completely figured out. Correct. Now we will go to or we can also check about the duplicacy. Okay, if we need to check a duplicacy in that, so we will write cars dot location, that is. Okay, and after that we will write cars dot duplicated. Correct. And let us run this cell. So this is the car ID and the symbolization of the few cars and all as in head part. Correct. Now comes, now we will visualize the data. Visualizing the data. Correct. Now code. Let's code this, and this coding is for the visualizing the data. Okay, how we visualize the data. First of all, we need to plot the figures. First of all, we need to plot the figure, then fig size is equals to, according to that you can give your any size. This is not compulsory at all. Okay, then you can plot the subplot, and for doing this you need to carry on with the detailing also. You can pass the parameters. Okay, and after that you can plot the title, plot dot title. The title I need is car price prediction. Okay, or distribution plot, we can say prediction plot. Okay, so if I say that as in Seaborn we need to synchronize the box plot, and that box plot has a value of 1 comma 2 comma 1, and the plot title would be or price spread. Correct. And after that again we will synchronize the box plot. Now we will enter a point that I need to get what I had been passed the parameter to get show. Okay, so particularly for the car price, then after that we have to synchronize for basic detailing, and again for the, and also we can displot also. If I'll say the SNS, plot, okay, box plot. Here we can synchronize also. Okay, there is no problem in synchronizing this. Okay, if I'll say simply write that I need to synchronize, it can be, that is not a problem. Let us run this. So you can see by running this program, so it is the basic distribution of it, and there are two parameters we pass upon this. First one is the car price distribution plot, another one is car price spread. In the very first we pass the parameters that is 1 to 1. Okay, and another one again we pass the parameters that is 1 to 2. Okay, in the very first it was giving us the car price, in the second also in the box plot it is giving the car price, but in the first it is this plot that is known as the distribution plot. Okay, so it is giving us this point. So you can see the graph of it, what it is, and this graph is giving us the very first graph, it is giving us of the relation between density and the price. The another one it is giving off the density and to the variable. The difference between the graph, you can see over here that how the difference is there, the particular visualization, the categorization, and the basic absorption of a figures. Okay, and similarly that if you need to have the basic employments of visualization of the data, you can simply visualize but in a categories also. So what if I need to have a visualization as an categorization of a data? Okay, if I'll say that this is the data I'm visualizing as an categorical data. Again I'm coding, but I'll delete this cell. And after that I will write a code for visualizing categorical data. For this I need to plot and the figure out the fig size and dot fig dot size should be 2080 or 28 we can say. Okay, and we will plot 1 to 1. And again for the plotting dot title we will write it as symboling histogram. And in this we will write the count plot. Count plot we will be getting the car symbol. Or we can say the palettes, and that palette should be in your cubical form, cube helix. Okay, in this the plot should be the subplot that varies the value of 1 comma 2 comma 2. And again, if I'll say the plot title, what the plot title, this is the visualization of the data according to the one figure out. Okay, comparison of it. If I'll say that, if I'm doing symbol line, versus price. Okay, if I'll again, I think we can make it as in string also, as we did in upper section. And we need to synchronize, or we can formula out the box plot. The x is equals to cars, y is equals to cars price, and then we will pass the palettes. Then we will say the plot show. So this is for the visualization of the categorical data, and this data to verify this code we will be writing this again the correct code. I think this is the correct one, the best format I can say. Okay, if we will be like making it run the cell, so you can check out that it will be giving us the two verification of, first of all is symbolization of your histogram, another one is a symboling with a price. Okay, both the relation is with count as well as the symboling. Okay, so as in variable keyword there would be a valid positional argument which will be rising and decreasing with the numerical format, I would say. Correct? In the numerical format you can just judgment out like how these are being giving us a proper detail. Now what happens, like if you are being considering this as in the basic suppressing or the box plot of that as in Levy engine or the volume engine or interquartile range, so there would be this would be the interquartile range, that is IQR method. Okay, so there is the algorithm also used in this, we can say if we need to. So there would be the algorithm used in this, that is the k nearest neighbor or any of it. So basically like this, we have a stock price prediction also, and in the stock price prediction we use to get the entire idea of predicting the stock prices to gain the significant profit, loss, the advantage of it, and the standardization of it and all. Okay, but this would be a basic degree of I can say the algorithm, the simple MA or exponential MA or any of that. Correct? Getting my point? So now we'll be writing for the numerical data. Okay, so now for the numerical data, what you can do is, let me just mention that numerical data. Okay, now we will add a code and delete this out. The numerical data, you can formalized visualization through a scatter. I'll say this, the def scatter, and I'll pass x is equals to fig. Okay, I think this would be the scatters only. So basically the plumb out would be there of it. So if I'll say the plot dot subplot is your 5 comma again the figure. Okay, again if I'll say the plot I need is the scatter. In the scatter we can have the cars, which is obviously we are doing of the car only. So in this we can check out the price also. Correct. And after that we will plot the title. Plotting the title, we can either give us as in string part versus price. Correct. As an at the y-axis we can give as the y label this as a price. PLT, that is plot, in the x label you can give it as an x. Now for the plot figure, this time I'm giving you a short this because you just need to understand this. If I'll say that it is the fig size and that size is standardized to 10 and 20, correct, and the scatter would mention few things, that is your car length, okay. I think this would be the shortest part. Okay, so let me just give it from here. Okay, so this would be the shortest part of your scatter plot, that is car length, car width, car height and q weight. Okay, and these given particular IDs, that is 1 2 3 4, and then we will be executing the formulation part. Now let us run this, and now you can see a basic new criteria, that is car length versus price. Okay, now you can see car length versus price, car width versus price, car height versus price, after car curb weight versus price. So you can see that explosives versus prices is there, like that means that the value is already passed to it, and the scatter plot is being represented versus car length and price, car width and price, then car height and price, then we have car weight and price. Okay, these all are the relation between price and car weight, length, curb width, or any of that. Curb weight I can say. Okay, so the price is an independent variable, that is on the x-axis, and whereas the basic change of your detailing part, that is on your car x-axis, I would say. Okay, so that would be a basic observation about how you can create it and how you can formulate this. Okay, now if I'll tell you one more example, just a minute, I'm being reporting to the pen tab. Okay, if I can say that what is generalized method. Okay, generalized method of linear regression or simple linear regression or mixed model also we can say about. Okay, so basically we have in a generalized linear model, mixed model, which is also known as GLMM, generalized linear mixed model, which is the linear predictor, in this we have linear predictor. In this we have linear predictor, and it contains random effects. Okay, it contains your random effect and it is non-normal data. Okay, now what if I can say that a data you needed is in sophisticated part. Okay, so these all the data which is the containing as in conventional part, So it would be your conventional part, conventional linear regression model, that would be continuous, and this continuous would be given to the categorical predictor, correct? And this categorical is also known as ANOVA and ANACOVA. We will not go deep to this, but we have the basic, I would say, just a minute, I think this is stopped. Okay, we have in the GLM, we consist of the three components. Three components is there. In very first component we have random component, very second is your systematic component, and the third is your link component or a function. Okay, now when we understand the GLM part and the statistics or the functional part, it gives us the more details. So now what are the more details of it? First of all, we need to remember that the GLM is only refers to or used to refer the conventional linear regression. Okay, and the conventional linear regression, these are the random forest, the systematic forest, and the link function. Now what is the random component? So in the random component, it will only specify the probability. It will only specify the probability, but that probability can be of the distribution, the responses that will respond the probability. And in this we have an example of normal distribution, okay, in the random component, whereas in the systematic components it specifies your explanatory components, okay, that will give you explanatory components, correct? Whereas in your link function we used to give the link between random and the systematic, correct? But that would be in the logit form, that is logistic regression it would be, and this can be observed as in particular fact. Okay, this is the basic graph. Also we have a basic graph of it, but I don't think so that it is much required, but I'll still give you a basic assumption what we can do. Okay, so and there is, if I'll say that what is the equation of the generalized one equation, what is the equation of it? So equation you don't need to remember, just to if in competitive exam if it is to be asked upon, so you are aware like what is equation is all about. Okay, there is nothing to explain because I will not also explain this, just to remember this certain point. And where in this pi I is okay, so this is your conditional expectation of y, whereas this is conditional mean. And also known as conditional expectation also. Okay, so basically this is your link function, this is link function, this is your regression, we can say the regression coefficient, and this is regression variable. Okay, this is regression coefficient and this is regression variable in this. Okay, so you just need to remember this, whatever there are. So we have model in this, we have Gaussian model, we have Poisson model, we have Bernoulli's model, but no use of this. Okay, nothing to be used in generalized part. Just need to remember few things in this, that is it is just a flexible generalized of ordinary linear regression. And examples we can take off, like generalized linear regression models we can take off, like traditional linear models, logistic regression, Poisson regression, that is your log model regression. The gamma model is there with log length. Okay, this is just a generalized part. So also that there are the commonly used families of the general linear model, and these are relating to number of continuous, the categorical prediction of every single outcomes we have. Okay, so basically you can see out how you can convert these models according to this. Okay, and also for the project of the car price prediction, for the car price prediction model, you can go through this code, you can work on this code, you can play with this code, and after that if you find any doubt in this, you can reach out in the comment section and let me know if you have been facing any of the particular error, or I will definitely try to solve it out. Okay, so I think tomorrow also we will continue with the same project and some of the basic terms also. Okay, so I think this much is okay for you. So we have the weekly live sessions on every weekend for projects. Okay, and also the data science live courses on YouTube channel of GFG. Thank you so much for watching this, for having it. Okay, subscribe to this channel and see you.